To start this, please let me call on the chairman of this technical session to the high table in person of Professor E.A. Taiwo, a professor of chemical engineering. Please let's appreciate him. Thank you, sir. Thank you, sir. Professor Taiwo is the former director of ITCU. You are welcome, sir. Also to join the chairman on the high table is the discussant or rapporteurs. We have two on the list. The first on the list is Professor O.O. Ilori from Department of Electrical and Electronics. Sorry, Electronics and Electrical. Thank you. You are welcome, sir. And Dr. H.A. Azan. Dr. H.A. Azan, please. Come and join us from Computer Science and Engineering, also from Obafemi Awolowo University. Thank you, sir. Please, to have a very interesting and conducive technical session, please let us rearrange ourselves. Let us come a little bit forward so that we are starting this technical session with those on the Zoom. Those that will present their own, that will have their presentation online, and we'll be starting with, okay, we'll be starting with a Type 2 development of mobile-based gamified technology tutor for children. And the presentation, the author of this manuscript are Hidi Ajiteru and FM Downsy. And the presentation will be done by Downsy. Please.
MC. Hello? MC? So they are not just going to speak and continue to speek. We have 8 papers and we have a lot of things to do after the presentation. So we have discussed here with the rapporteur and we agreed that the center will have just 10 minutes of presentation. Since we have some people online, I think we will take those who are online first. And when we are done with that, we can then come to those who are here physically. We allow each presenter to present for 10 minutes. How many are online? 3. So we take the 3 online. After that, we can have our questions in 5-10 minutes, and then come to the physical. All the 3 online presenters we consider first, and then come to the physical. So as they are presenting, you can take note if there is any questions you want to ask, comments you want to pass, so that after the presentation we'll allow you to ask questions. Yeah. Once again, I welcome us to this technical session. As I've said earlier, we have a lot to do, and so we are giving each presenter 10 minutes of presentation. We will take those who are online first, and after dealing with that, we'll come to the physical. Each presentation or each presenter will have 10 minutes to make presentation, we can take note, comments or questions after the three as presented. Then we come to the comments and questions before we come to the other sections. Those three that were online, I think the MC will let us know. Okay, over to you.
Thank you. Thank you, sir. Chairman, sir. First on the list, we have development of a mobile-based gamified technology tutor for children, Lenify. And the authors are Hidi Agiteru and FM Dancy. Mr. Dancy, over to you. The second presenter is ready. The title is Mobile App-Based Teaching, Research and Supervision Management Platform for Faculty Member. And this is going to be presented by P.O. Oyimaja and FM Dancy. Please, Mr. Dancy, over to you. You have just 10 minutes to do justice to this, and the time starts now. Please kindly unmute yourself, Mr. Oyemaja or Oyemaja, P.O. Oyemaja. We are waiting. Okay.
Good afternoon. Good afternoon.
Afternoon, no, we are listening. Oyemaja, P.O. We are waiting.
Share your slide. Okay, sir.
Please share your slide.
I'm trying to, sir.
You are online,
though.
Oyemaja, you are online.
The host is not allowing me to share my slides, sir.
Please try again.
Okay, sir.
Is there any issues again?
No, sir. I'm sharing it now, sir.
The audience are waiting.
Good afternoon, sir. Good afternoon, everyone. Standing on all existing protocol, I appreciate all the names, the professors, and the faculty, and also the entity at large for giving me this opportunity to present my work. My name is Oyemaja Chris from the University of Technology, Akure. The name of my project is Mobile App-Based Teaching Research and Supervision Management Platform for Faculty Members. Now, this project aims at revolutionizing education through innovative technology, streamlining teaching, research, and supervision for faculty members. Now, we all know that we are in the age of increasing technology use, and one of the ways we can improve ourselves in Nigeria is integrating and building the use of technology into our learning systems. Hence, this project. Now, we know that the future of any growing nation is investing in technology. The future of education is also in technology. Now, the aim of this project is to revolutionize engagement by transforming how lecturers interact with their work. Also, by improving how lecturer-student relationship is. Right now, in our educational system in Nigeria, in most universities, there is increase in number of students we have in our schools, in our universities, and there are not enough um, structure to cater for all of these students, especially in the 100 and 200 level where all the students are together. So this project aims to build a bridge between that by providing and catering for all of the students at once. How this is going to be done is simple. So this project considered the magnitude of the students and also aims at making the work of lecturers easier. So this project provides a platform for teaching, for research, and for supervision. How this is done, the teaching aspect is done by uploading of videos into a platform, and students will have access to those videos. Then, in terms of research, lecturers, students can upload their research, and users of this particular system can have access to those research works and use them. So this technology is creating a bridge that will enable both students and lecturers have a very comprehensive and very productful use. Now, if you look at the screen, you see my methodology overview. You see how the relation between the users and the lecturers. Now, when a user signs up into the system, he doesn't just have access to everything on the system. The user will sign in. The user will identify if he or she is a student or a lecturer. And based on whether it's a student or a lecturer, the system will provide some information. Now, if the person is a student, the technology will prompt the user and the student to enroll for these or our courses. So when you enroll for those courses, it's going to assign to a supervisor. Now there is a supervisor meant for each of the courses, and each of the supervisors will grant you access to the content of the courses. So in a faculty, if you have a faculty, let's say conventional faculty, a student will create a user profile. When he logs into the system, he requests to be enrolled into courses. And when he is enrolled, the student will have access to all the lecture notes, all the videos concerning that course. That way, the student does not, the lecturers don't need to have physical classes. Although physical classes are very important and very useful, but since we're trying to reduce the number of students in class, because we have a problem of overpopulation in Nigeria right now in the university system. We have a problem of population in the system. This will reduce the need for a large crowd in a particular classroom. This will reduce the need of a large crowd in a particular classroom. So now, this will make teaching easier because students can go over these videos, this learning videos, over and over again, take down notes, and at a particular time, the lecturer can have a general class where you can just go through all what they have learned, all what they have learned. So this will make lecturing easy. This will give lecturers more time to focus on their research, to focus on all their remaining activities apart from teaching. And this also gives students the opportunity to learn at their own pace. So the tools that will be used to do this project is the Flutter framework, and for that part is using Firebase. So the features of this particular system is as follows. When we launch the app and you are registered and you are in the system, you see all of your information at a glance. You need to access the menu. You need to see your course materials, and you need to have access to the research hub. Now, this research hub is not limited to a particular faculty per se. This is a system for a faculty, and also a system for other faculties in one. What I mean is that, for example, if you are in the Faculty of Engineering, you have your own system where you can log into and you get access to it. If you are in the Faculty of Agriculture, you also have your own system. But at the same time, there will be a centralized hub of the research hub will be centralized, such a way that all the faculties research will be into one database, where in each faculty, when you log in, you need to have access to even other research work. So the content management features, we have video uploading. Lecturers can upload videos of courses, and the benefits is enhanced learning. We have document publishing, where students and lecturers can post and publish their work on the app, and others can go through and read. We have the secure storage of academic information, data management systems. Now, this technology provides a secure infrastructure and a secure storage for research works. So students, lecturers can post their research, and even after years, you still find it there. Now, the impact and future potential of this research. One is bridging the gap between physical and virtual classroom. In the future, there's going to be a possibility of integrating AI into the system, such a way that it will help students to learn more, structure their learning in such a way that it will help them to learn. Perhaps an AI will be integrated into the system where it can explain a particular subject, a particular course that he or she is also watching, in case he or she does not understand. Thank you for listening.
Thank you very much, Dr. Yemaji. I was about to tell you that it became to random. And we appreciate it. We want the next person to come up, after which the rapporteur will remind us before we go for questions. Who is the next person?
Thank you, sir. The next on the list is Saka, design and simulation of multilingual safety system for vehicles on construction sites. Please, we are waiting.
I'm here, sir.
Okay, thank you. You are online.
Yes, sir.
And your screen has been shared. Please, go ahead. You
Yes.
have just 10 minutes.
Thank you, sir. Good afternoon, everyone. My name is Saka Khadija from Department of Computer Science and Engineering. Thank you very much for being here. The title of the paper I'll be presenting today is Design and Simulation of a Multilingual System for Vehicles on Construction Sites. Okay. Sorry. The construction industry has been recognized as one of the most hazardous sectors globally, with fatal accident rates 3 to 6 times higher than other industries. It has been established by health and safety executives that about 7 workers die each year as a result of these accidents involving vehicles on construction sites, and 93 are seriously injured. Although there are several traditional approaches that help in reducing vehicle collisions, some of which are training programs, signage placement, speed control, PPE, and visual warning system. But all these traditional approaches can be compromised by human limitation, and these limitations are fatigue, stress, and distraction, which can reduce compliance and their effectiveness. Therefore, there is a need for a more proactive approach to tackle these vehicle collisions on construction sites. There are several existing methods in tackling vehicle construction sites. I'll be going through 4 of them. One of which is a system that uses gas sensor and IR sensor to detect toxic gases and static obstacles in vehicle. It sends alerts via alarms and SMS, but this system has a limited range of 3 feet, which is a short distance. Replacing this sensor with an ultrasonic can help to improve the detection range and effectiveness. There is also another one by Joe et al., where they developed a proximity warning system using RFID and AVM. This prevents accidents between workers and heavy equipment, but it was only made for excavators, and it relies on visual alerts only. Adding voice alert to it can help enhance safety of the system. We have an AI-based collision detection system which uses GPS and camera for real-time alerts and auto-braking. This system is effective, but in areas where there are poor internet connectivity, this system will not be able to work. Finally, we have a crash avoidance system by Naraya, where they use ultrasonic sensor and automatic braking. But this system effectively reduces collision, but then it applies brake without warning, which can be a little bit uncomfortable to the driver. Here is the conceptual diagram of the safety system. Here you can see that each vehicle has the safety system mounted with components such as ultrasonic sensor, voice alert modules, and a central microcontroller installed. The system is adaptable to various vehicle types, each with the capability to detect obstacles and alert the driver regardless of the vehicle size or function. So this is how the system works. Once the engine is started, that is once the driver wants to start his vehicle, they have to select his language for the voice alert system. They choose the language that they are familiar with, and then the embedded ultrasonic sensor in the system continuously monitors the areas and checks for obstacles. When an obstacle is detected, the obstacle is detected and it is between the 3 and 6 meters. The system activates the first voice alerts in either of the language the driver selected, and then the vehicle speed will automatically reduce. Then, when the obstacle is detected in a distance less than 3 meters, the second voice alert will be activated and the vehicle will automatically stop. Here is the circuit diagram. That is how the connections of all the components were done. Each component were chosen for specific and justifiable reasons. That is, the Arduino was chosen for its ease of programming and versatility, and it is also cost effective. The ultrasonic sensor was chosen because of its accuracy in providing precise distance measurement. The DF player was selected because it employs multilingual voice alerts catering to the diverse linguistic backgrounds of the workforce. A speaker is used to ensure clear output of alerts, making them audible even in noisy environments, because the construction site is always noisy. This is the flow chart of the safety system. That is how the system works. You select your preferred language. The system will check for obstacle. If an obstacle is not detected, it will just continue and maintain current vehicle speed. But if an obstacle is detected and it is between the distance 6 meters and 3 meters, a voice alert will be sent to the driver, and the vehicle speed will reduce. That is, it will go at a slower pace compared to how it was going before. Then when the distance is less than 3 meters, the second alert will be sent and the vehicle will automatically stop. We varied the voltage and distance and recorded the sensing duration, that is the time at which the obstacle is being detected. And then the sensing duration was then plotted against the distance. And we can clearly see that it is linear, that is, the sensing duration is directly proportional to the distance of the obstacle to the vehicle. From the simulation conducted using Proteus, there are valuable insights. There are two key observations that we got. The sensing duration is directly proportional to the distance of the obstacle. As the distance increases, okay, sir. As the distance increases, the time taken to measure this distance also increases. That is, when the obstacle is close to the vehicle, it will quickly send that alert, and this is what we want for timely vehicle response. The implementation of voice alerts at the threshold of 6 meters and 3 meters highlights the effectiveness of audio alerts in enhancing driver awareness. In conclusion, we can say the Proteus simulation shows that this system responds promptly to obstacles at varying distance, with audio alerts ensuring that drivers are continuously aware, which is essential for preventing accidents on construction sites. The difference between our work and existing work, that it has multilingual capability. That is, the system offers multilingual voice alert, allowing workers from different linguistic backgrounds to easily understand safety warnings. By communicating in the worker's native language, the system reduces the risk of miscommunication. That is, the driver, no matter the linguistic background, is able to understand the warning that is sent to him. Also, it has an integrated voice alert with automated control. Unlike the traditional approaches, that system that only rely on either visual alert or manual intervention, this system makes use of the two: voice alerts with automated vehicles response. That is, the voice alert will come on first and warn the driver. Then automatically the system either reduce or stop depending on how far the distance is from it. In conclusion, the safety system designed for vehicles on construction sites successfully enhance worker safety through real-time obstacle detection and voice alert. Simulation results that we got from the Proteus confirms that the system effectiveness in preventing collisions by establishing a direct link between the sensing duration and obstacle distance. Thank you very much for listening to me.
Thank you, presenters. I'm meant to know that we have only 2 online presentations. So we allow the rapporteur to talk for 2 minutes to remind us of the paper that was presented, and then we ask our questions.
Okay, thank you. Infrastructure deficit in higher institution of learning. Oyemaja and Downsy proposed the deployment of mobile platform with the use cases in such areas as teaching, research, and supervision. Flutter frameworks and Firebase database were used for system implementation. Targeted end users are faculty members, that is academic and non-academic staff. However, on the deficit, no literature review given, nor neither system architecture nor demo presented. In addition, neither evaluation metrics nor result stated. AI incorporation was identified as one of the areas for future improvements. That's the summary.
Thank you. Second paper.
Okay. The second paper by Saka, Design and Simulation of a Multilingual Safety System for Vehicles on Construction Site. The objective of the paper is to enhance safety in construction sites. The paper reviewed existing methods and their limitations. The paper also described the conceptual diagram of the safety system proposed to overcome some of these limitations. In addition, the paper presented how the system is meant to work by obstacle detection and warning alert, providing alerts to the drivers or operator, and also it has multiple safety systems, not only providing alerts in the language that the operators understood, but also to reduce and to automatically stop the vehicle that is being operated. The presenter went on to provide justification for component selection, of which low cost and simplicity of implementation was emphasized. Though the paper presented results of simulations, and the result of simulation shows the effectiveness of the audio alert system. In addition, the presenter provided the difference between his or their work and other work, and gave the important novelty in the work, which is the multilingual capability, and also the fact that they integrated voice alerts with automatic control. So in conclusion, because this is a simulation work, the simulation confirms that safety of the worker is enhanced. Thank you.
Thank you, our rapporteurs. Can we appreciate our rapporteurs? If we want to have question or comments, can we indicate by raising our hands? And those who are online as well, you have question, comments, you can indicate by a show of hand. 1. I have number 1, number 2, and number 3. There is no question after question, so number 4. So we have only 4. So within the next, nobody online yet. So within the next 10 minutes, we'll deal with that. You indicate the paper you are asking, on which you are asking a question, and then you ask your question. We will take all the questions. Those presenters, please be listening and take note of your questions. Thank you. Dr. Balimore.
Good afternoon, ladies and gentlemen. The name is Ayorinde Balimore from Chemical Engineering Department. My question goes to presenter 1, who presented on mobile app-based teaching, research, and supervision management platform for faculty members. My question is, how does this mobile app, how does it differ from other online platform? that have been created for this purpose and that have been very effective. For example, what we are used to is the Google Classroom, which has been largely effective. So how does your design compare with other platforms?
Good afternoon. I'm Afiz Olaguju, a postgraduate student of computer science and engineering. My comment goes to the second presentation, the design and simulation of multilingual safety system for vehicles on construction sites. This is a very crucial research because we are moving towards driverless vehicles and something like that, and the research is very crucial in the area of safety. But I would suggest that you look into the to the cybersecurity aspect of the project, like, because if an intruder get access to the system, they might pose a very crucial risk in that area, because when they hijack the system, they might make the vehicles to collide and do all sorts of things. So you need to work on the cybersecurity aspect, preventing intruders from accessing the system. Thank you.
Good afternoon, everybody. My name is Bello Kamaruddin Temidire. My question goes to Ms. Saka Khadijat. So my question is, since you said that the vehicle is going to slow down or stop eventually when an obstacle is being detected, what if the driver tries to risk it, or try to force it to move to a wrong direction? Will it stop eventually, like the car itself? That's my question.
Thank you very much. I'm Surura Bello. To the first presenter, I want to know how many actors. At the beginning you talk about supervisor, and later you are mentioning lecturer. So I want to know, are these two actors the same, or you are actually referring to two different entities? Thank you.
Thank you very much. Questions? I will allow each of the presenters 2 minutes to react to the questions that have been asked. The first presenter, that's Oye Magia. You have 2 minutes, so you are on. Are you there, Oye Magia, please?
Yes, sir.
Okay. Your reaction.
The first question says that how does this software differ from other platforms? I'll answer that now. The first difference is that this particular software is personalized to the university and the school. It is personalized with faculty. And how it is personalized is that there are other platforms that provide you videos of whatever you learned in class. But this particular platform allows the lecturers to post their own videos, teaching you what they want you to know. The other platform, they are not giving you general teaching, but here, your lecturers by themselves are giving you those lectures. So it's like taking your lecture in class, only lecturing out this time. And this one of the difference is the research management system. Here you will have access to every publication and every research work being done in the school. So you have access to it's going to be a research hub for your school, for for the university and for the faculty. So you will need to have access, and it will make whatever is being done in the university known to the students, because most times students don't even know about the research work of their lecturers. So this will bridge that gap, and students will be able to interact with the research work. They will be able to post their own research work too, and to promote more a productive engagement facility between the lecturers and the students. And the second question says that how many actors are there? So there are 3 actors. First, we have the super admin. We have the supervisor, which are also the lecturers, and then we have the students. That's it now.
Is that your response, or you still have some other information to pass across?
Okay, I still have one more thing to say, which I failed to. Are you hearing, sir?
Yes, go ahead. 1 minute.
All right, sir. Thank you very much, sir. So, this software is providing
We can't hear you.
Go
ahead. We can hear you now, since you are not talking.
This software is providing an opportunity and a platform for students and lecturers to work side by side and work hand in hand, and also prevent accidents in classroom due to overpopulation and overcrowding. And this will further improve the educational system in Nigeria as a whole. That's all, sir.
Okay, thank you very much. You were reacting to the number of actors, and I think you mentioned students and the lecturer. I said lecturer is also the supervisor. And you said you have 3 actors. Probably I didn't get the 3rd actor yet.
I said the first actor is the super admin.
The admin,
so
okay.
The super admin,
Right.
and administrator that is above all other administrators of the platform. Then we also have the lecturers, which are also the supervisors.
Thank you very much. Let's go to Saka. Saka to react to those questions and comments.
Thank you, sir. The first person made the...
You have 2 minutes.
Yeah. Thank you, sir. The first person said we should look into the cyber security of the project. And this... So thank you very much for mentioning it. But then the system will have strong authentication for access control mechanisms. So we will surely look into that. But for the second person, the person asks if the driver tries to move, even after there is a warning or so. So to answer this, when we wanted to, for this paper, when we wanted to start, we actually went to a construction site and we asked, what are the things in place? They mentioned that there is a warning system, a visual warning system. But then, even with the warning system, the drivers still run into accidents, and this is because of they don't listen to the warning. They don't react to the warning themselves. So that is why it is now automatic. That's why the automatic braking system is in place to make sure to automatically reduce the speed and automatically stop as far as the obstacle is detected. So it does not wait for the driver to respond. It is the vehicle that will do the responding. It is the vehicle that will either reduce speed or stop the vehicle. I hope I've answered the question. Thank you very much.
Thank you. I think the questions go further to ask if the driver will not even act on that action by the car. Suppose the vehicle slows down and the driver decides to accelerate. So is there any provision for...
Yeah, there is, because the ultrasonic sensor is continuously checking for distance. As far as an obstacle is there and the distance is between 3 to 6 meters, it will be on a slow speed. It won't allow for the driver to accelerate or do any of that. And if it is between lower than that, it will stop. Because the ultrasonic sensor is continuously checking the distance and sending the information to the Arduino.
So meaning the design is such that the system will not act on the action of the driver when an obstacle is
as long as an obstacle is detected. Yes, sir.
Thank you very much. Can we appreciate them? The MC will come to the physical presentation, and the presenters still remain online because there might be questions that will come to you at the end of the presentations by those who are here physically. Over to you, MC.
On our list for the physical session, the first presenter Ogunsola Oji Spinning and Sentinel. It's PhD international process. The title of the paper is pH neutralization process modeling and control using long short-term memory network-based non-linear model predictive control. And authors are Bamimore D. Igoche O. Ogunsola O. Ojifini OS and AS Oshuleke. Over to you, the presenter.
Good afternoon, everyone. My name is Oluwaseun Ojifini, and I'm here to present a paper on pH neutralization process modeling and control using long short-term memory non-linear model predictive control. So the paper is jointly co-authored by, as you can see, Bamimore, Igochi, Ogunsola, myself, and AS Oshuleke. So, next slide. So, the pH process is a vital process in industry. For example, in pharmaceutical industries, where the pH of drugs of active ingredients in drugs are to be controlled, it's very, very vital to ensure that there's adequate control of pH. Also in biological systems, where enzymes act and then they are really affected by pH, it's very, very necessary that we ensure that pH is adequately controlled in those systems, and also in chemical reactions that won't proceed if the right to pH is not met. So we need effective pH control to regulate the process. So, however, a common challenge with for pH interaction process is the non-linearity behavior it possesses. So our pH system has a complex dynamics. That's complex dynamics. So, however, it makes the control of it challenging. So conventional methods like linear models have been used, but because of this non-linearity behavior, it's very difficult to achieve a perfect control because they cannot adequately capture the dynamics of the pH neutralization process. So to address these challenges, researchers have explored machine learning-based models. So next slide. So example of some of the research work that has been done. Some examples are Bamimore et al. 2021A and Palanta, where they examined feed-forward neural network for pH process control. So one of the strengths is it's actually performed well, high performance, but the weakness is there's short-term data dependency associated with the feed-forward neural network. Another work is by Senna et al. 2021, where they use integrated feed-forward neural network with extended Kalman filter to achieve offset field control for neutralization process. However, there is the strength, it achieves offset-free control for the PH process, but the weakness, there's also short-term data dependency associated with the feed-forward neural network. Also, Bamere et al. Presented 2021, we presented a comparative analysis between of feed-forward neural network and recurrent neural network as applied to cascaded 3 tank. The strengths, it actually articulated the advantages and disadvantages of both feed-forward neural network and recurrent neural network. So the weakness is there's gradient vanishing and explosion problem of the recurrent neural networks. So next slide. Also, some limitations of feed-forward neural network and RNN as a machine learning model. So feed-forward neural network is not well suited for modeling time series data, which is what we usually have in most processes. And then also recurrent neural network, especially the traditional ones, they suffer from exploding and vanishing gradient problem. Also, LSTM is also a type of RNN, a type of recurrent neural network, but it has been improved, an improved version that can solve the issue of exploding and vanishing gradient problem. So the gap identified in previous studies, LSTM model has proven effective for time series data. However, there is limited research in its integration to non-linear model predictive control. So the highlight of this present study is to integrate LSTM into NMPC design framework, and also to see how to evaluate how the LSTM network can adequately capture the non-linearity behavior of the PH interaction system. So next slide. So process modeling with LSTM. So as you can see, the equations 1 represents the process model done by the LSTM. So the YK there is the output, and the function f of represents the model, like the dynamics of the system. So moving on to equation 3, that's the summary of the LSTM model representing the dynamics of the world. So the LSTM actually acts like a black box model to capture, it's a data-driven model, so it captures the input and output data. So the summary of it is in equation 3, where the output is a function of the model. So next slide. So now the LSTM, as I said earlier, is an upgraded version of recurrent neural network. However, upgraded neural network that solves the exploding and vanishing gradient problem. So it does that by using gates to regulate the flow of information. So as you can see in this architecture of the recurrent neural network LSTM, you can see it has a forget gate, input gate, state candidate gate, and output gate. So the forget gate forget gate is useful in forgetting. Is used to like remove past information that are not needed by the network, and then we have the input gate, the state candidate gate, and output gate. So also the LSTM is made up of two major states, which is the hidden states and the cell state. So the cell state represents the long memory of the network, that it encodes the historical data for the network. The hidden state is what is outputted by the output gates. So next slide. So this equation simply represents the what's happening in the gates. The forget gate, F there is for forget gate, I input, G state candidate, O output. Next slide. Also, what's happening in the cell state, hidden states, and then the final output state. So the final output state is what gives them the final prediction value. That's equation 11. Next slide. So LSTM based NMPC. So NMPC, the full meaning of NMPC is non-model predictive control. So it's a control methodology that uses, or is a type of internal model control, IMC, that uses the process model, to try to predict future values over an horizon, and then uses an optimizer. So for LSTM, for NMPC stands for nonlinear. So that means it applies to nonlinear processes. So what our LSTM is doing is that it's replacing the model inside the NMPC is replacing the model inside the NMPC. So equation 12 shows the cost function that must be minimized. So as I said earlier, there's a model and an optimizer. So the equation 12 represents the optimization problem that will be solved. So also, another advantage of NMPC is that it can be subjected to constraints, whether linear, non-linear, equality, inequality constraints. Alright, sir. So next slide. So the pH process that we applied the controller to. So next slide. So as you can see from the diagram, we have the base flow rates, the acid flow rate, the buffer, and then the pH. So the base flow rate is our manipulated variable, and the pH there is our output variable. The pH is what we're trying to control using the manipulated variable, the base, that's U3. Next slide. So the controller design methodology. So this is the methodology we follow for designing the controller. First, we collected data, and then after that, we processed the data. So the data processing involves removing noise, normalizing. So next, we selected the model structure and the order of the network, and we chose appropriate machine learning model to use. That's for our case LSTM, long LSTM. So we trained the network. Next slide. Then we tested the network based on the new data. And after that, we deployed the LSTM trained model into NMPC framework. So after that, we run a closed-loop simulation. Closed-loop simulation simply involves the controller. So to compare, to see how it works well for servo and regulatory simulation. So servo is the same thing as set point tracking, and regulatory is the same thing as disturbance rejection. So finally, if there is a real plant, it can be deployed to test the rig. Next slide. So this is data we got, the input output data we got using our base flow rates, as you can see in the figure below, and then this is the output we got from it. So we got 7,200 input output data by sampling 10 seconds from the Simulink model. This was modeled in Simulink. Next slide. So the LSTM neural network architecture that we use contains one sequence input layer, two LSTM layers, and then a fully connected layer. So this is the architecture of LSTM, and then the training algorithm that was used is ADAM, learning rate 0.01, and maximum epoch 5,000. Next slide. So the open loop simulation result, as you can see here, from table 1, you can see the MSC, which is mean square error value for the linear model, and then LSTM model. So the linear model provides a MSC value of 0.28, while our LSTM has a value of 0.094, which is way better. As you can see also in figure 5, in figure 5, you can see the blue line represents LSTM model prediction. The red one is linear model, as you can see, and then the black one is for the actual process. You can see that the blue line for the LSTM model prediction was able to track the set points for pH than the linear model, which is red. So observations, LSTM model fits well with the real system and performs better than linear model. Next slide. So next slide. So also we plotted the input output data, that's the pH against the base flow rate. Okay, sir. Thank you, sir. The base flow rate. So the black value represents, the black rounded dots represent the actual process data. The blue one, LSTM model prediction, and the straight line, also the diagonal line, linear model prediction. So we can see that the LSTM accurately captured the non-linear behavior. Accurately captured the non-linear behavior of the pH system. Next slide. So also for the closed loop simulation results, so we introduced some set point change, and we can see from the diagram the set point is the red one. The LMPC is linear model predictive control, and LSTM NMPC, that's the blue one what we designed, and then FP NMPC, that's from first principle. We can see that our LSTM actually performed better in tracking set points. So next slide. So for disturbance rejection, so the disturbance is the buffer flow rates. So when we introduce step changes in disturbance, you can see that our LSM, which is the blue one, was still able to track set points even better than the linear model. Next slide. So this is a comparison of the models, MSC value for servo control performance. You can see that. Okay. Thank you. So in conclusion, our LSM network was able to capture the dynamics of the pH process, and then when we saw the results from servo and regulatory problem, it actually was able to perform well even in the face of disturbance and plant model mismatches. So thank you for listening.
Thank you.
GP, thank you, even though you overshot the time by about 5 minutes. Yes, I was already warning you. I said you should round up. You already exhausted your time when I said
The manuscript is titled Determinant of Internet-Based Technological Innovation in Nigerian Industrial Clusters. Authors are M.O. Olomu, G.O. Binuyo, O.J. Onipade, O.H. Okuru, A.M. Ademola Ajibade. Please present them. You have just 10 minutes. Please be time conscious.
Good afternoon, everyone. My name is Okuru. I'm here to present a paper entitled Empirical Investigation on the Determinant of Internet-Based Technological Innovation in the Nigerian Industrial Clusters. My introduction, my outline runs from introduction to conclusion. Technological innovations plays a pivotal role in industrial growth, as the industrial sector is regarded as the early adopters of the disruptive technologies, in parentheses, internet. Technological innovations are equally significantly drive sustainable development goals and globalization. Next slide. Continue, sir. Sorry for the break in transmission. The disruptive technologies like industrial Internet of Things, AI, are essential in driving the performance of the industrial sectors. They equally facilitate connection, automation, and high-performance computing, significantly boosting the productivity and effectiveness, competitiveness of industrial sector. They are equally instrumental in addressing economic and business challenges facing by industrial sector in the global world. They are very important as they contribute to the growth of the economy. They foster synergetic collaboration among firms, enhancing technological innovation capabilities, and provide competitive advantage and development in digitalized economy. The